This video is going to go through the second and third way to prove that triangles are similar. So this is chapter 8, section 3, and those two are called side, 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 and side, angle, side similarity. So in addition to angle, angle, we'll have two more. The first is side, side, side similarity. This is a theorem. And it says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So for this one, which is usually easy to spot, we need all three side lengths of each, and they have to be proportional. Meaning if I were to use these triangles here, the biggest side is 10, and the biggest side and the small one is 5. So 10 to 5 would have to equal the middle side length of the first one, which is 8, over the middle of the second one, which is 4, would have to equal the smaller over the smaller, which is 6 to 3. And since all of these simplify to 2 over 1, these triangles are similar. And my reason is side, side, side similarity. So we can't just use SSS because that's proving they're congruent. We have to say similarity at the end. And then just like before, if we want to do a similarity statement, we can write it just like this. So in this case, triangle ABC is similar to triangle DEF. The third and final shortcut to proving triangles are similar is side angle side similarity. And that theorem says if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So for this, we need two sets of sides and the angle where they meet. So that's the most important thing, is the order of the letters is side angle side. The angle that's provided has to be the one where the two proportional sides meet. So you'd have to know that angle A and angle D are congruent, and then 10 over 5 would have to equal 8 over 4. And since they would both reduce to 2 over 1, I would know these triangles are similar, and my reason is side angle side similarity. So now we've got all three. Angle angle similarity, in which you have two pairs of angles congruent. Side 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 similarity, in which you have three sides all proportional, three pairs of sides. And side angle side, in which you've got two pairs of sides and the included angle, or the angle where those sides meet. Okay, so example 1. A says the measures of the sides of triangle ABC are 4, 5, and 7, and the measures of the sides of XYZ are 16, 20, and 28. Are the triangles similar? So in order to do this, you have to line them up. You don't actually have to draw this out because you can match them up by their measurement. 4 is the smallest of the first, 16 is the smallest of the second. So 4 over 16, 5 is the middle, and 20 is the middle, 5 over 20, and 7 and 8 are the biggest in each, 7 to 28. If I simplify all of these, reduce to 1/4, 1/4, and 1/4. So the answer would be yes. If it asked why, my answer would be side, side, side similarity. B says in triangle ABC, AB is 2, AC is 5, BC is 6. In triangle XYZ, XY is 2.5, YZ is 2, and XZ is 3. So again, line them up. Small with smallest of this one is actually the 2, so the order is different. 2 to 2. Middle of the first would be 5. Middle of the second would be 2.5. 5 to 2.5. And largest with largest would be 6 to 3. So looking at these ratios, these two both reduce to 2 over 1, but that first one clearly does not. So these would be not similar. Example 2 says if triangle XYQ is similar to XZP, does it follow that XPQ is similar to XZY? So the first two are XYQ to XZP. So if those two are similar, obviously their angles are all congruent. You've got X that is shared by both. and then you'd get y is congruent to z, and you'd get that their sides are all proportional. So pz to qy would equal xz to xy would equal px to xq. So then the second part of this question is xpq similar to xzy? So they both have x, which means you've got the angle between the two sides. All you have to do is prove that xp is proportional to xy and that xq is proportional to xz. Now, based on what we just wrote from these, we had xz was proportional to xy. So we're actually saying this whole side is proportional to this whole side, and the xp is similar to xq. So xp here to xq. Since you can take a proportion and match the numerators with the denominators, we can say xz to px would be equal to xy to xq, and that's our xz to px and xy to xq. So now you've got side angle side similarity there, which proves these are similar. All right, last set of examples. Example 3 says name the similar triangles and give the postulate or theorem that justifies your answer. So if we look at A, one of the angles is already marked. This is 80 and 80. That means you have one congruent pair of angles. And then these two triangles both share angle A. If I look at the small triangle and the big triangle, which means this would be an angle-angle similarity. So triangle ADE would be similar to triangle ABC, and the reason would be angle-angle similarity. Go to the triangles in B, and this time you've got two sets of sides given, so I would check their proportionality, and both the small and large triangles have angle C, which means you've got the included angle if the other two are proportional. So if 6 to 6 plus 3 or 9 equals 10 to 10 plus 5 or 15, which would be 2 to 3 and 2 to 3, because those are proportional and they both share angle C, this would be a yes, and this would be side angle side similarity. And we need to name those similar triangles. So triangle, if I went DCE, it would be similar to triangle ACB. And the order of those letters are important. Okay, looking at C, there are two triangles. You've got your top triangle here and the bottom triangle here. Nothing about the angles, no vertical angles, no parallel lines, which means we have to go straight off those sides. So in the small triangle, 3 is the smallest. And in the big triangle, this is 6 plus 6, so this side is 12. The smallest would be 6. We want that to equal the middle length, which would be the 5. Over in the big triangle, 10. And we want that to equal the largest in the small triangle, which is 6, over the largest in the big triangle, which is that 12. All of these reduce to be 1/2. So this is also a yes that it's similar. The reasoning being side, 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 similarity. And if we name the triangles, the smaller triangle, if we go KLM, we went smallest side to middle length side. So when we name the big triangle, we have to do the same. Smallest side is 6, middle side is 10, which means this would be K-O-N. And that would be the order the letters have to go. Again, they can be rearranged, but if you rearrange one triangle, you'd have to rearrange the order of the other so that the K's are both in the same spots, the L's are both in the same spots, and the M and N, the L and the O, sorry, are in the same spot, and the M and the N are in the same spot. All right, that wraps up the notes for 8.3. Make sure you submit the notes to today's classwork assignment. Have a great day, guys.